Welcome to 25th lecture on probability and statistics. In this lecture, we will study two important concepts, permutations and combinations. Here's a recap before we start permutations. This is about the MN rule that we studied in last lecture, that if the events are happening in two stages, the stage 1 has m possibilities and the second stage has n possibilities versus each and every m. We use the MN rule. For example, we have 3 books, and in our bookshelf we have space for only 2 books. So we have 3 books A, B, and C, and we can put only 2 books on our bookshelf. So what are the possible combinations that we can place the books in? Right, we can select this first in 3 ways, the first book in 3 ways, A, B, or C first. Suppose we select A first, and then we have 2 choices for the second book, either B or C. And suppose we choose the first book as B, and then we have 2 choices for the second book, A and C. And similarly, if we choose the first book C, we have 2 choices for the second book, A and B. So we have these 6 combinations. We have 3 options here, 2 options for every option in the first category, or in the first stage. So in the first stage we have 3 possibilities, and for every possibility in first stage we have 2 possibilities in second stage. So MN rule says it should be m times n 6. But there are easier ways to do this. For example, counting rules for permutations. Permutation is a simpler, or it's computationally feasible, or it's computationally simpler rule for permutations. Permutations means arranging n objects taking r at a time. So P n P r, it's read as n P r, n first, then P, then r. It's n factorial over n minus r factorial, and we know that n factorial is n times n minus 1 times n minus 2, and we go on and on until we reach 1 multiplied by 1. So this is n factorial. For example, 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1, 4 factorial is 4 times 3 times 2 times 1. So this is how we compute factorial. So suppose we have 3 tickets that we have to draw from a lot of 50 tickets, and order is important. We use permutations when the order is important. For example, in this example, the order, for example, A and B. The first book is A, the second book is B, and AB is different from BA. If order is important, AB is different from BA, we use permutation. And if this order is not important, if you are interested only in the case where we book which 2 books, order isn't important, then we use another concept that we'll study later in this lecture. We call that combinations. So we use permutations when the order is important, when AB is not the same as BA. When AB and BA are different, we use this formula to select R items out of N. This formula, permutations. So if we use this formula for this application, so homework, the answer would be 6. Apply this formula. It's a homework for you. Apply this formula. Which formula? This formula on this problem. We have 3 books, and we have to take 2 books at a time. Apply this formula by putting n is equal to 3 and r is equal to 2. Right. Right, so the answer will be 6. 3 factorial, n factorial, let's put this formula in. 3 factorial divided by 3 minus 2, 1 factorial. 3 factorial is 3 times 6, 3 times 2 is 6, 1 factorial is 1, so the answer is 6. So if you use this formula, the formula for permutations on this simple problem, the answer is the same, it's 6. So we can apply this formula any way we want, where we have to select R items out of n objects, R at a time from n objects, where order is important. A, B is different from BA. Order is important. So I repeat, when the order is important. Right. So For example, we have to draw 3 tickets from lottery where we have 50 tickets. Order is important. What are the 3 ways? How many ways we can select these 3 tickets? For example, the tickets are 1, 2, 3, 4, 5, 6, 7, 8 up to 50. So we can select 1, 2, 3. We can select 1, 3, 4, 1, 4, 5. So how many ways? In how many ways we can select this? For example, if we have tickets 1, 2, 3, 4 up to 50. So combination, in how many ways we can select? Order is important. So we can select 1, 2, 3. It's one way we can select 3 tickets. 1, 2, 3. 1 we can select 1, 2, 4. It's another way. We can select 1, 2, 5. So in how many ways we can select 3 tickets? Order is important, means 1, 2, 3 is different from 3, 2, 1 is different from 2, 1, 3. So for that, we don't have too much. We don't have to try all combinations. That will of course be cumbersome, difficult to do. So how to do this experiment, how to reach the result quickly, we can do that by putting 50 and 3 in this NPR formula. So we can say there are 117,600 ways in which we can select 3 numbers out of these 50 numbers where order is important, where 1, 2, 3 is different from 1, 3, 2 is different from 2, 1, 3. Right. So this is very interesting. So you don't have to work very hard by trying all combinations. You can just plug this in this formula, in this NPR formula, and you can get the result straight away. So it's a very powerful formula. We use it most of the times in statistics and probability. So another formula that can be thought of as the sister of this permutation, combination. It is combinations. Combination is the sister, or it's the brother of permutations, with a very small difference. We have to select our objects out of and distinct objects, but this combinations formula is used when the order isn't important. In this example, where 1, 2, 3 is the same as 2, 1, 3 is the same as 3, 1, 2. Going back to our last example, we use this formula when AB and BA are the same. Doesn't matter which book is selected first. It does matter that you select which 2 books, A and B, A and C, or C and B. When the order isn't important, only the items are important. Then we use another simple formula that can be thought of as sister of permutations formula that we have just studied. It's the formula, we call it NCR. NCR is the sister of NPR. Right? Permutations. We use it when the order is important. We use NCR when the order isn't important. AB is the same as BA. We use NCR, I have also mentioned it here. We use NCR when the order is not important. We use NPR when the order is important. For example, if we select 3 tickets out of these 50 and the order is for example, it's not important, then we'll use, instead of using this P, we'll use the C, NCR formula. That would be n factorial over r factorial times n minus r factorial. This formula. So it will give us lesser number of ways. Of course, lesser number of ways, because 1, 2, 3 is the same as 2, 1, 3 or 3, 2, 1. So we need to purchase, here's an example, we need to purchase 3 machines from 5 suppliers. Order isn't important. So how would you purchase? We can from 5 suppliers, we can select 3 machines from supplier. 1 from 1, 1 from 2, 1 from 3. 1, 2, 3, 3, 1, 2, 2, 1, 3. So how many ways in which we can select when the order isn't important? It's 5 factorial over 3 factorial, because n is 5, r is 3. So putting everything in this formula will give us 10 different ways. Continuing this same example, for example, we rank the suppliers on the basis of the quality of product they deliver. For example, if exactly 2 are from the best 3 suppliers, what is the probability that exactly 2 of the 3, so not 5, 2 of the 3 machines that we select are from the 3 best suppliers. So we have 3 best suppliers and 2 not best suppliers. It can be thought of as a bin containing 3 best suppliers and two not best suppliers, and B. 3 best suppliers, 2 non-best suppliers. So what's the probability that we get 2 from here, 1 from here? So we have 3 best suppliers. What's the probability of getting 2 from this? So first we have to compute their combinations. 2 from 3, 3C2, NCR. Putting 3 is equal to, N is equal to 3, R is equal to 2. And then 1 from the remaining 2, 2C1. So it gives us 3 and 2. Using MN rule, we have 6 different ways in which we can select 6. So probability of A is 6 divided by the total number of ways we can select is 5C3, it's 10. So 6 over 10. 6 over 10 is 2 by 5. It's 0.4. So it's 40% probability that we will get 3 that we will get 3 machines, and out of those 3 machines exactly 2 are from the 3 best suppliers and the remaining 1 is from the remaining 2 non-best suppliers. So this is how we can use combinations. We'll keep on studying more about probability and different rules of probability in our upcoming lectures. Thank you.